Hi guys, bit of vintage stuff to have a look at. This is, in case you haven't guessed, a very elderly telephone exchange. I believe it's an 8-line. This was removed from a customer's premises as we started to move them to SIP. Thank God they weren't still using this, they had a Toshiba system instead. But this thing is quite primitive. It appears to work in quite an interesting way. So I figured that we'd have a quick poke around it and have a look. This is a really good example of if you're into building your own computers, doing a lot of digital experimentation and everything, there is a lot to salvage in here. I've had a quick chip count and gathered some data on what's on here, which is why screws are out. And there's quite a few useful parts in here, including an 80186 processor with not very much, a ROM, a RAM, a CIA of some kind and a UART. You can build a reasonable little machine, and pushing into the realms of PC compatibility, depending on how much RAM you put in and how you put it together, isn't that difficult. Your problem will come with BIOS, but HP 100LX used that, so maybe there is a BIOS around there somewhere that you can have. Anyway, we've got two boards in here. We've got a fairly simple power supply. Excuse the manky plaster, I managed to try to take my finger off earlier on. But yeah, we've got standard linear power supply in here. There's nothing special about that. That will be generating some interesting voltages because we've got to provide ring voltages and other things. So we'll have a quick poke around that, but we won't dwell too much on it. You have a processor section here based on the 80186, and then the board underneath this is more or less a straight copy of this daughter board on top. So let me grab a pointy thing from over here. It's all quite simple, although I don't understand much about telephone line matching because I don't have much to do with analogue pots other than squirting VDSL along it. So you've got multiple channels here. These are labelled PSTN, 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 PBX, PBX, PBX. So it looks like you've got at least 4 incoming lines, 4 outgoing lines on this top board, and I would suspect the same is true of the bottom board. It connects in. I will take it out. So we've got a power connector there. We'll get rid of that because we don't need it. We've got some kind of loop back board there that's to do with power. Not sure what's going on there. We have an earth line, which is from the very large multi-way connector and multi-way cable there. 24-way I would guess. Then each one of these is linked down to the next board with a little jumper cable. Interestingly, hopefully you can see it, these large resistors have been pushed through cutouts in the board from the board below, so I assume this can be cascaded up to more boards. Quite what this would be able to hold, I don't know. There's possibly room for maybe one more board in here. I mean, if we go that resistor there and we go onto the case over here, you'd be pushing it. All that disconnected board just lifts out, and it's interesting to note the bottom board isn't actually connected. Doesn't appear to have ever been connected. Let's just have a look at these labels again. So we've got PBX, PSTN, PBX, PSTN, PBX, PSTN. So we have 1, 2, 3, 4, 5, 6, 7, 8 there. So that would appear to be pairs of PBX output lines and PSTN input lines. Without the manual it's hard to tell, and the odds of finding the manual for this are slim to none. Let me just grab something to cut with. It says completely failing to find anything. I have unfortunately been working, or fortunately been working somewhere else for most of the week, downstairs in the bar, which means my tools are scattered between 2 parts of the building. So we'll slide that ferrite off and we'll pull this cable out, which is still not going to happen. There we go. We're out. And we don't actually need this anymore. It's just going to get in the way, so we will just pull those out of the IDC connectors. No, I'm not being particularly gentle, but this thing's never going to see service again. I have powered this up incidentally, it does power up. So there's that top board. So we've got, as I said, we've got 8 there. 1, 2, 3, 4, 5, 6, 7, 8. So we've got line relays there, and for each one we have isolation transformers. We have a set of chips which are doing the conversion from the telephone line voltages to something that this can cope with. And then, curiously, although I guess at the time this was made, it was probably the only way that they could really do it, we have each one of these is a DTMF decoder, and there is something else odd in there which I missed. Okay, I'm not quite sure what that one's doing, that's just an op amp. But then what we've got here is all digital. We've got a local regulator here, and then these are 82 C55s, so they are CAAs, complex interface adapters, or actually no, they're not, they're interface expanders. So these take an 8-bit data bus and the appropriate address signals, and then give you multiple ports. So if you're familiar with the PIC Micro or the Atmels, it gives you something very similar to the ports on those. I would imagine they are being used to drive relays and receive the DTMF signals, and possibly a little bit of signal control and routing on here. There's no analog routing being done on here other than perhaps something by the relays. That's all done beneath. So we'll pop that out. It's a single-sided board with a DIN 6164 connector on. There really isn't anything special. There looks to be some expansion capability there. I'm not quite sure what you'd be expanding there, but it's quite a typical old board layout. So on the top, most of your tracks are going that way. On the bottom, most of your tracks are going that way. It's quite common, and there is actually a little bit of surface mount in here. Not much. Bottom board, pretty much the same. We've got a bulging cap there. It appears that we only actually have 1, 2, 3. We only have 4 PSTN and 4 PBX channels. So for your average small business, that would probably be enough. I suspect this can handle call transferring. I doubt it would do that any more than that. You're certainly not going to have voicemail. You know, call transfer is probably about the limit of what it can do. You got basic features, hold, transfer, things like that, but you won't have any more. We've got 2 more I/O expanders under here, and then we have what appears to be the glue that holds it all together. This chip here is an analog switch. It's a 8x12 analog switch, so this will be your switch matrix, where all your lines are being switched through, and that will determine what connects to whom. I believe, looking at it, you would be able to handle concurrent calls through it, but this is dealing with near line level audio, so this is going to be involved in the down conversion of that to line level audio. Telephone lines can hit up to about 50 volts, and the AC ringing tone can be really quite nasty, enough that you'll feel it if you're on the receiving end of it. Not fatal, but not pleasant. Then there's a little bit of weirdness down here, which I didn't expect to find in something quite so old. We have a baud rate switch here, selector here. This jumper is set 9600, and I assume that would be some kind of onboard UART for interfacing. We are not short of UARTs on this. I will show you those in a second. However, this chip here, I believe it's this one, yep, is a complete single chip modem, and that's feeding directly into here. So I'm guessing this has some kind of maintenance mode where it can dial in or be dialed into. I can't see any other reason why it would be there. The old telcos installers love making ways of making their life easy, but making a hell of a lot more money doing it. Yep, we'll just dial in and we'll change one setting and we'll charge you £300 for that. Yeah, a bit jaded when it comes to the telco engineers, but there you go. I've always had issues dealing with them. So looking around this board, as I say, we've got our complex. We've got our interface expanders here. We have these here, which are, remind myself, 68100s. They are static RAM. So there is 128k by 8, so there's a reasonable chunk of RAM there. I'm not sure what you'd actually need it for in something like this, other than remembering what call's been switched to where and how long the call went on for. You're not doing anything complex, so that seems more than I'd expect. We have an EEPROM, which obviously contains the operating system. We then have 3 UARTs, which not quite sure what's going on there. I suspect we have a pair here between this UART and the modem. We may have a connection between this UART and here. We'd have to pop the board out to look, and I can see tracks moving in that direction, so that's quite likely. We do have 2 sets of level shifters there as well, so that could be what's going on there. Not really interested in digging much deeper to find out. We have our processor with a clock generator there. That's a Intel, it's not an Intel, it's an AMD 80186. So that is an 80186 processor with most of the companion chips on board. So you've got your timer, I believe there's a DMA controller on there, and there's an interrupt controller. So as I say, with just this, you are fairly close to having a fairly simple PCXT. That may well be what's going on there. It wouldn't be surprising to find something that's been developed on a PC and then moved over. Certainly these were designed to fairly easily interface with the ISA bus, so that may be what's going on there. You don't know. And that's about it. There's nothing really interesting going on. We have a power supply here. I don't think that's producing anything other than ring voltages and a large 5-volt supply. We have multiple fuses, I'm not quite sure why. We have in there, I hope you can see this, a battery that's done the dirty. That's long gone, and that would, obviously, I would expect issues with that. I can plug this in. Quite happy to plug it in. It does something. Power lights come on. I don't know if any of these LEDs should actually do something at this point. I can, just out of curiosity, if I grab a multimeter, we can have a quick poke, but all we can really do is see whether we've got a 5-volt supply, which I would imagine we almost certainly have. 5.09 volts, that's pretty much bang on. There's not really any easy way of getting, let's just find one of those again. So we've got a ground. There's no real easy way of getting at those supplies to see what we've got. So we've got 5 volts, 5 volts, ground probably, 5 volts, not sure. I will short one of these sooner or later. 12 volts. I would expect something higher in terms of, there we go, 24 volts, negative 24 volts. We've got positive 24 volts. No, the negative 24 volts can potentially serve as the current for the ring generator. That's assuming that the phones designed to use for this were standard phones. They may not have been standard phones and therefore might not have needed the ring generator. That, incidentally, is drawing 7.2 watts. Interesting point to make. If you do telecom systems and you're doing upgrades to SIP, a standard Toshiba Stratus system with no phones on it draws about 350 watts. We measured this the other day. That may not be the stock current, that may be the result of some of the caps getting a bit old or something. That's a lot of current to be drawing constantly if you compare that to an IP replacement where you're going to be drawing a couple of watts per phone. If you're off premises, cloud hosted, and even on premises, a modern IP exchange will not draw anywhere near that kind of power. So some of these were real power hogs. This one, not too bad, but again, there's no phones on it, and we've taken one of the boards out. So what's the fate of this? Basically parts, there are a number of parts here that you could use. We've already touched on the 186, the RAMs, they're usable. The UARTs, again, they're usable in your own project. You've got the basis of a single board computer here. If you were really brave and you went and did some reverse engineering of that ROM, you could possibly twist this system into doing something else. I'm not sure, other than the satisfaction of doing it, what use would be. If you're doing a lot of work with Arduinos, then potentially these are worth rescuing, because you can use them. You'll need an 8-bit port to drive them, but in theory you get 3 ports out of each. So a little bit of careful working with those two, you get six I/O ports, and if you use the others, you can get 12 full 8-bit I/O ports to play with. That anywhere where you're going to be doing audio or low-level audio switching and routing, so perhaps as a source selector for an iron build stereo system. Modem, I'm not quite sure what you use that for. The tone decoders, they are potentially useful, especially in ham radio circles, or even if you're building equipment that's expected to work with radios that support DTMF for end of transmit or start of transmit. So they can be useful for repeater builders. Relays are always useful. 470 ohm power resistors, they'll be useful. Analog electronics op amps, that op amp has got a hole in it. They're always going to be useful. Transconductance amplifiers are strange little things, but again, potentially useful. And there's all sorts of other small jelly bean 74 series logic in it. You've got a large transformer here that's good. There is no sign of a rating on it. There are heat sinks, there's a bridge, there's another large power resistor down there. So there's plenty of stuff in here worth salvaging. There is, I suspect, a real-time clock down there as well. Looking at that, I think we've got a real-time clock. RS-232 transceivers. Yeah, so certainly worth taking it apart, worth putting it to one side to raid for parts, or as I will most likely do, raid it for parts and then dispose of the bits we can't use. I wouldn't trust any electrolytic capacitors out of this. They're not particularly great ones, although they fall well outside the time of the great capacitor plague. Eco capacitors, I have heard of those before. Line isolation transformers could potentially be useful. So yeah, I mean, ultimately this is for the parts bin. I don't think even the box will be getting used. It's just a straight pressed steel box with holes in it. I could in theory slam a nice switch mode in here and use it for another project, but it's not difficult to get cases now. So anyway, there you go. A very ancient, very crusty telephone exchange. A really quick run through it. And another video for you. So I hope you enjoyed, and I hope it at least made sense. And hopefully once the chaos calms down, we can get back to videos at a normal kind of level. Thanks for your time, and thanks for joining us. Bye.